take a look at the idea of sequences with a focus on arithmetic sequences in this example. A sequence is just a series of numbers that you see separated by a comma. You're going to be able to recognize a pattern here in each of these sequences. Only one of these is an arithmetic sequence. The other is not. As you can see, I've indicated for my green check mark that the first one is an arithmetic sequence, and the second one for my red X there is not an arithmetic sequence. But let's talk about why the first one is an arithmetic sequence and what we're looking for to determine if it is an arithmetic sequence. So when I look at this first sequence, I'm looking at the difference between the terms. I'm looking at to go from the first term to the second term here, I have a difference of 3. And from the second term to the third term, I also have a difference of 3. And the third term to the fourth term, I have a difference of 3. And from the fourth term to the fifth term, I have a difference of 3. We call that the common difference. If the difference every single time from term to term is the same, we call that an arithmetic sequence. And we say that the common difference for this sequence would be 3. The common difference can be positive, it can be negative, depending on whether the sequence is increasing or decreasing, but it will just be that number that's being added each time. So if the sequence were decreasing, you would be adding a negative, and the common difference would be a negative number for that. The second one here is not an arithmetic sequence. If you look at what happens from term to term, to go from term 1 to term 2, it looks like I've added 3. But from term 2 to term 3, I've added 5. And from term 3 to 4, I've added 7. And term 4 to 5, I've added 9. Now, I can certainly see a pattern starting to emerge there. Adding 3, then 5, then 7, then 9, the next odd number each time. But that does not have a common difference. That difference varies, and that's not true of an arithmetic sequence.